Carbotopia, Driving Carbon Efficiency by Grave-to-Cradle Terrestrial Carbon Circularity. In our current society, we buy 10 gigatons of fossil carbon for a total worth of 2.5 trillion US dollars on an annual basis. These fossil fuels, just like many things in nature, are made up of life's major building blocks: carbon, hydrogen, and oxygen. These latter two obviously occur as water. As a result, these building blocks are an integral part of chemical synthesis, with unused matter being broken down into gas. Taking into account this information, it's easy to see why 2.3 gigatons of terrestrial carbon being pumped into the atmosphere would be a huge issue. Considering what we know, it would make sense to promote carbon usage within the circular economy, especially considering its role as main constituent of crude oil. Carbon circularity could contribute to economic stability. Reusing terrestrial carbon could mitigate potential methane emissions and could transpose natural CO2 emissions into carbon-neutral varieties. This way, we can also assure that we generate qualitative economic growth from new local employment. The most relevant reuses for recycled carbon are three main options. We can either focus on renewable electricity and using carbon efficiency and carbon recycling as a way to back up the renewable electricity grid. We can focus on polyolefin refining under employment of excess electricity production for carbide smelting. We can also use renewable hydrogen in mobility, steel, or agrochemicals. These three options show crude oil substitution rates of 2 liters per kilogram of carbon. Carbotopia's hydrogen production by CCU thermodynamics outperforms any other state-of-the-art carbon emission-free hydrogen production. The use of this hydrogen can increase carbon efficiency to a 75% state of recovery, which can be even increased up to 95% if excess electricity electrolysis is available. The carbon, as a powder, can be stored, transported, and used with water at any time. Carbotopia is not only complementary to other decarbonization technologies, but it is key to overall economics due to its contribution to total resource efficiency. Where there is wastefulness, there's poverty. Unattended waste burdens habitats and food chains. Especially the questionable use of petrodollars amplifies pressure on poorer regions. Diligently using our natural resources would lead to more qualitative growth, benefiting both the people and the planet. Carbon circularity will challenge existing value chains while opening up new avenues. Assuring the balance of the vital water cycle would also be considered a useful side effect.